Hello, my name is Ravinath Kannangara. Today I am presenting our work on using machine learning to automate the triage of primary care referral to vascular surgery. Currently, GP referrals to vascular surgery are manually reviewed and triaged by hospital clinicians. This process is labor intensive and delays patient flow through the healthcare system. Machine learning techniques in natural language processing have advanced, providing a viable alternative. There is only a limited number of studies in this area and all of them have used binary classification methods. Our proof of concept study looked at the feasibility of using machine learning methods in implementing a multi-class classification pipeline for primary care referrals. Primary care clinicians were requested to provide referrals for hypothetical patient scenarios in varicose veins, peripheral vascular disease, and non-vascular conditions. These letters were augmented using GPT 3.5 model and the clinical classification for referral type and urgency undertaken by hospital specialists using previously validated scoring systems. We then built a data processing pipeline that employs standard natural language processing techniques such as label encoding, tokenizing, and sequencing. Data was split 80:20 for training and testing. We evaluated 7 machine learning models that ranged from classical algorithms like support vector machines to advanced transformer models like BERT and the domain-specific Clinical-BERT. For each model, we calculated precision, recall, accuracy, and F1 scores. These parameters for neural networks are shown here. Looking at our results, we found that all our models could easily identify referral types such as varicose veins or peripheral vascular disease with near perfect accuracy. The real test, however, was classifying clinical urgency. Here the result varied significantly across the models, and the BERT emerged as the superior model comparatively. In summary, we augmented 63 GP letters to 408. BERT was the top performer, especially for the critical task of classifying urgency with an F1 score of 0.87. The model rankings were robust, holding up even when non-vascular referrals were added or removed. So why did general BERT outperform the specialized Clinical-BERT? We believe it's because referral letters blend clinical and common language, which the broader model understands better. Our analysis also showed that some models were heavily reliant on non-vascular cases and their performance dropped when those were removed. As a proof of concept, our main limitation is the use of small synthetically augmented dataset. The models have not yet been tested in a live clinical setting. Our next steps are to validate these models on a large-scale, real-world patient data and explore integration into exciting clinical workflows to measure real impact on patient outcomes. In closing, we believe this research is a promising step towards a more efficient and consistent triage process that can directly improve patient care. Thank you for your attention and I'm happy to take any questions.